Homework section 5.3, number 8. We are going to prove the following identity. Sine of theta equals 3 times sine theta minus 4 times sine of theta to the power 3. So we're going to start with the expression on the left-hand side, which has multiple angles. So the left-hand side with the expression sine of 3 theta. Sine of 3 theta. 3 theta means we have the theta added by itself 3 times, or we can rewrite it as 2 theta plus theta to see as a double angle that we can use a formula or the identity to replace it. When we see this form, we can treat it as sine of the sum of an angle A and angle B. Put on the notes here, sine of the sum A and B is sine A cosine B plus cosine A times sine B. That means our right-hand side, the expression that we have, the sine of an angle 2 theta added by an angle theta will be in the form of sine of 2 theta multiplied by cosine of an angle theta plus the cosine of 2 theta times sine of theta. And then we see the cosine of the multiple angle or the sine of double angle here and cosine of double angle there. On the side notes, the sine of the double angle is 2 times sine theta times cosine theta. Where the cosine of the double angle, you have multiple choices. You can have either the cosine square theta minus sine square theta, or 2 times cosine square theta minus 1, or 1 minus 2 times sine square theta. From the web assign problem, the sine 2 theta, we're going to replace with the expression 2 times sine theta times cosine theta, and then multiply by cosine theta, plus the expression for the cosine double angle is provided as the use of 1 minus 2 times sine square theta, and then multiply by sine theta. I'm going to write in a better handwriting there. My ink doesn't work well. So the cosine 2 theta is replaced with the expression 1 minus 2 times sine square theta, and then multiply by sine theta. And after that, we are going to simplify what we have. If we see the cosine times the cosine theta, and we write those expressions as the power 2 of the cosine theta. The right-hand side, the other group, we're gonna distribute the sine theta into the parentheses or into the grouping symbol to have sine theta minus 2 times sine to the third of the theta. And after that, we are going to replace the cosine square theta with the Pythagorean identity, which is from the sine square theta plus cosine square theta equals 1, or the cosine square theta is the same as 1 minus sine square theta. That means we have 2 times sine theta times 1 minus sine square theta, and then added by sine theta minus 2 times sine to the third of the angle theta. Next step, we are going to distribute 2 sine theta into the grouping symbol to get 2 times sine theta minus 2 times sine to the third power of the theta angle plus the sine theta minus 2 times sine to the third power of an angle theta. And after that, we combine like terms as we see 2 sine theta and sine theta combine to be 3 of the sine theta. And then the other one, which is the expression negative 2 sine to the third power of an angle theta minus 2 sine of the third power of an angle theta combined to be negative 4 times sine to the third power of an angle theta as the expression that we see on the right hand side. And now we are done proving this identity.